Hello everyone. In the previous video, we saw the types of PPP. We began with the types of PPP at the power plant, and we saw the single basin, single effect, and double effect plants. So we are continuing with the types of PPP, and the next one is double basin with linked basin operation. So as you can see in the figure, we have got two basins. So high basin as well as low basin, and then sluice gates on both the sides, and then you have the power plant. So basically it's like you have three barrages. In this arrangement, a large basin is converted into two basins of suitable dimensions, and the one at the higher level is called the high basin and the other one the low basin. It consists of three barrages, one separating the high basin from the sea, and it is known as the filling gates, and another separating the low basin from the sea, and they are known as the emptying gates. And the third barrage, which separates the high basin and low basin, contains the powerhouse. The upper basin filling gates are opened only during the time when the sea level is higher than the upper basin, and the emptying gates are opened only when the sea level is lower than the lower basin. And the head on the turbine is the difference in elevation between the upper and lower basins. The two-basin scheme may be economically viable where power demand is less than the guaranteed output as determined by the tide cycle. The two-basin system can be operated by retaining water in the high basin and releasing it to meet during the peak demands only. And here you have the double basin with paired basin operation. Earlier the basins were linked, but here they are only paired, which means working simultaneously or working in parallel. So in effect, this is like one of the, it is like you're having two single basin, single effect plants. So let's see the double basin with paired basin operation. This consists of two single basin, single effect separate schemes located at a distance from each other. The locations are so selected that there is a difference in the tidal phase between them, and both the schemes never exchange water, but they are interconnected electrically. Both the basins operate in the single basin single effect mode. One basin generates electrical energy during the filling process, while the other during the emptying process. This arrangement affords a little more flexibility in operation of the plants to meet power demands. More benefit can be derived if there is a difference in tidal phase of the sea near the two basins. In case where there is no difference in tidal phase, the variations in power output can be evened out by resorting to ebb tide operation in one plant and the flood tide operation in the other. The paired basin operation leads to a continuous output, and still its power supply remains irregular, and there is no solution for equalizing the great difference in output between the spring and the neap tide operation. Further, it is difficult to find two tidal sites within reasonable distance of each other, having the requisite difference in time of high water. If you have any confusions in this ebb tide operation and flood tide operation, this was discussed in the previous video, and also what an ebb tide is and what a flood tide is was also mentioned. Basically, when you have a high tide and low tide, ebb tide is the flood tide is the tide which is coming from the sea to the shore, and the ebb tide is the tide which is going from the shore back to the sea. Now let's see the advantages of PPP. The tidal power is predictable, and available tidal power is firm as there are no wet or dry years and no dry or wet months, and nor is there any influence of summer or winter on the availability of tidal energy. And the tidal power plants do not require a valuable land as these are located on seashores. Tidal power, when used in combination with a thermal plant, can meet effectively the load demand. And once the capital cost of a tidal power scheme is paid off, the cost of power generated is very low. The disadvantages include the tidal power plant output varies with the variation in tidal range. Its supply is intermittent, and the capital cost is not at all economical when you compare it with the solar or wind, like the conventional sources of energy. not solar or wind, but with the conventional sources of energy. And the silting of basins is a problem with tidal power plants. Thank you.